Hello, today's video will be about two sets of rechargeable batteries, AA's and AAA's, that will be tested for their initial performance. First of all, I would like to tell you a bit about these batteries, where you can find them, and what are my initial expectations of them. So, first of all, both of these sets cost around 10 euros or the whereabouts, and they are being sold in the European retail chain Lidl. So this brand that you are seeing over here, it's not from a well-known manufacturer. It's probably third party or outsourced to particular manufacturer. Of course, unfortunately, we don't know whom that particular manufacturer may be. We can expect probably well-known manufacturer or one that has production facilities. I'm expecting these batteries to be manufactured in China, so I don't think we will have more information about them other than the required ones for sale in the European Union. Let's look upon the back and see what kind of details are being provided. So, as you can probably guess from around here, this is your typical nickel metal hydride cell. It's nothing special. You can see some specifications over here. 2500 milliamps hour at 1.2 volts. This is entirely standard. Charging time 7 hours at 500 milliamps. Of course, you have to take into account that the charging time depends on your particular charger, and of course you can charge your batteries at higher current, but this will reduce lifetime. And in most situations you will not probably see right away how much current your charger delivers. And for the AAA batteries, you can see 1000 milliamp hour at 1.2 volts and 7 hours of charging at 200 milliamps. And on the front, you can see that they advertise 1000 hours, 1000 charging cycles. This is typical. Most products actually strive for this value. Unfortunately, it's very difficult to say if they are going to be living up to that expectation or not. And another important detail, fully charging and discharging a battery is much more stressful than charging it from particular capacity, like, I don't know, 50%, 70%. So in general, deep discharging stresses the battery more than charging it when it's not delivering the amount of power it is. So it's not only the amount of the number of charges, but also how much the battery is being stressed going from a low charge to a high one. Okay, what else can we say? The typical construction doesn't seem to be of any particular interest. It's your typical battery. The wrapping itself, I have to say that it's quite horrible, and this is a style I abhor in most circumstances, because you can hurt yourself when you're trying to cut the package. The package leaves quite dangerous edges that can hurt the skin, and the package itself is quite strong, which means that you have to have a good scissor, or you have to use a lot of force in order to unpack them. So this is one of my particular gripes with this kind of packaging, but other than that, we have to live with them. As you can see, you have 8 batteries in this set, and you have 8 batteries in the other set as well. So it's quite balanced, as you can right away guess. Other than that, no, I don't have any particular gripes. What kind of use scenario I'm thinking for these batteries is probably your typical device, like, I don't know, a flashlight, a portable radio. Even if they advertise cameras, I'm not entirely sure if they are fit for cameras, and different small power tools and remote controls. In general, I don't think that cameras in particular are very good with rechargeable batteries, because compared with lithium-ion batteries and compared with alkaline batteries, they don't have the same power characteristics. So other than that, I think that you can right away use them. And particularly when compact digital cameras are not a concern anymore, very few people actually use them today, I think that we shouldn't have too much concerns about them. And of course, as you can see over here, we have the classical UNI-T multimeter featured again. The reason being that most of our current and voltage measurements were done with it, so we have to be consistent in our measurements. And other than that, of course, it's a very good multimeter, still available. Of course, the model has slightly changed in design from around 8 years ago, when this particular unit was purchased. Now it has a different screen, a larger one, but I'm expecting the performance and the specifications to be largely the same. So let's look upon the batteries and see what we can find. What kind of comparisons we may have for this kind of batteries? Of course, just about any reputable manufacturer, whether we are talking about Japanese ones, European, American ones. I think that just about any product can be compared with the others on offer. Alright, I will take 2 batteries. I think this is going to provide enough information. I may even take 3, because in general it's being considered that to have a reasonable sample we should use at least 3 batteries. And we will see what happens. As a matter of fact, okay, let's take all of them and see how much variability there is between one and the other. I have also to mention that these batteries are pre-charged, which is standard these days. Some 20 years ago there were still batteries not being sold in their charged state, but this happens today without any sort of issue. We are starting with these small batteries, these AAA batteries, because I'm expecting there to be a difference between the smaller and the larger batteries, although it may, of course, just as well not be the case, because the manufacturer has used probably the same technology with both batteries. What I'm expecting, the capacity should be slightly lower on the AAA batteries than on the AA ones. Other than that, I'm expecting the voltage to be roughly the same. So in order to make a good assessment, first of all, I'm going to measure the maximum amount of current delivered. As mentioned before, this is one of my main concerns with batteries. First of all, because a good battery manufacturing capability translates into a very high current delivered on the spot when the battery is charged. On the other side, a poor one can not clearly sustain the same amount of current, so it's clearly going to be a differentiation factor. Of course, there are others, and you have to take that into account as well, and they are much more difficult to measure. But you will see in practice, if you charge a battery, how much of the initial charge it still keeps as after, I don't know, a couple of months, because I'm not expecting it to be any sort of to have any sort of relevance. What happens after 1 year or even more? I mean, why you are buying such batteries if you're not going to use them? And if you are going to use them in a device, it's going to be much more important to know how much they will be able to work like that. So without further ado, let's turn the measurement range to current, because this is what we are going to measure, and see how much each and every battery delivers. in amps, of course. So I have used the scale for 10 amps and let's measure. It doesn't matter if I'm measuring the polarity as is or the opposite way around. The multimeter is still going to show the same value. Okay, 3.8 amps. I think this value is quite good for a battery of this size. Let's see how much variability we have. 3.75, good value as well. 3.59, good value. 3.73, so there is clearly some variability, but I'm not expecting this to be 3.80, so good value. 3.87, an even higher value, so we had two batteries that have had consistently measured above 3.8 amps. So if 3.6, but possibly it could be higher. 3.98, okay, so this one is the highest it has ever been. 3.7. So most batteries will be between 3.6, let's say, and 3.9. All right, I think we have pretty good values over here. In order to leave them a bit to settle, I will start measuring the AA batteries and then get back at them and see how much voltage they deliver, because this will be part of an important assessment in terms of capacity, because capacity depends not only on voltage but also not only on current but also on voltage, because if the voltage is slightly higher, the same amount of current being delivered can be considered as a greater power storage capacity. Sorry for the noise. In terms of build quality, I am feeling these batteries right along the lines. I notice most good quality batteries, so there is no concern about them. The outer plastic shell is quite nicely built. The connectors are quite well protected, so this means they should be able to withstand a bit of mechanical abuse. They are well defined. I think that the nickel construction of the tips should have proper current carrying capability and be able to resist the use also in quite harsh environments. Nothing special about them, but I'm not expecting them to rust immediately. This is my initial expectation. Okay, let's measure. 4.69, so almost 4.7 amps. This clearly shows that they are using a battery technology that scales very well from a smaller to a large one, which was expected, but as you noticed in one of my videos, is not a given. Okay, 4.6, so slightly lower. 4.85, quite a high value. 4.73, roughly in the same ballpark. 4.87, so quite a good value. 4.65, not so high. 4.66, roughly at the same, on the same spot. 4.6. So as you can see, most of the batteries were around 4.6 amps. All right, let's get back to the others and see what kind of voltage they provide out of the box, considering that they were charged probably to the same value. I'm not expecting them to be charged entirely at the same value, but I think that it's enough. I chose not to use the more precise voltage measurement because I think it's going to be enough to measure with 2 decimals. In general, it offers enough information, and most multimeters will be able to use that value as reference. Of course, I could have slightly increased the measurement sensitivity, but I'm expecting it to be enough in this case. And I want to show a real world scenario, not one that is doctored well in advance. Right? Yes, I made a mistake. I have not moved the probes to the correct connector. Okay, so 1.25, it's at the level I was roughly expecting. 1.25, 1.26, the same value, nothing special. 1.26. Alright, so the voltage is consistent, and then the only difference is a slight variation in the maximum delivered current. 1.26. 1.26. 1.26. 1.26. And 1.26. Alright, what can we infer from this value? The fact that the difference in current carrying capacity in the maximum, in the short circuit current, if you want the right description for the situation, is the same. So most of the, or if I mentioned wrongly, most of the difference that comes is not from the voltage, which would probably signal a different charging state, but comes from the battery manufacturing variability. The fact that they can have a slightly better or slightly worse current carrying capacity depending on the batch and the particular situation that occurred for each of these batteries. In general terms, you don't have to be overly focused on variability, only if you have certain applications where you really require to have a very good current, or where you're expecting probably to work with batteries at a very low temperature. This information might be actually useful in order to extract the maximum amount of energy. 1.26, I'm expecting the same values. 1.26, entirely consistent. 1.26. 1.26. 1.26. 1.26. 1.26. 1.26. So just as in the case with AAA batteries, the AA ones have the same voltage. So everything that comes as a difference in maximum current delivery ability is due to the particular build of each and every battery and probably manufacturing variability. So what we can infer out of the box? Well, I think that for rechargeable batteries that cost around 10 euros, value-added tax included, I think that they have quite a good initial performance. However, just as with any sort of device that has a major requirement of behaving well in the future, we will only have the chance of assessing the particular quality of such batteries only probably 1 or 2 years down the line. Also, as in the case of most manufacturers, unfortunately, or in the case of this particular brand of batteries, we don't have too much of a way to say if something is going to change in terms of the manufacturer and the process that is being used by a particular manufacturer. So the battery may be sold with the same brand, but however, it could be manufactured by or at a different facility and with different technology. Unfortunately, this is one of the situations you're going to face with batteries that do not have a well-known brand and are being sold in retail chains. You have to take these details into account. You may be asking why I purchased these batteries. Most of all for the purpose of tests, because I'm interested to see how the typical battery would behave. I'm not expecting top of the line performance. I'm not expecting very low performance. I'm expecting average or perhaps above average performance, and with quite a good outcome. But then again, you may be better served by choosing a well-known manufacturer, even if it may be priced slightly higher. So, I hope you enjoyed the video and saw what a typical batch of retail brand batteries are going to offer. So, thank you very much for watching and have a pleasant day.